We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video, we'll be discussing a problem that is shortest unique path for every word. Previously, this problem has been asked in companies like Google and Microsoft. So you can consider giving me a +1 in the chat if my voice is clearly audible to everyone and the screen is perfectly visible, because I'll be starting out with this problem. And this is a very important problem. This problem can be done using two ways. So I'll be telling you both the ways and I'll be showing you the code for the most optimal way in which it can be done. Basically, this is an implementation of the try data structure. So it's a very good problem if someone is starting to learn tries. Like, what you have to do is, in this problem you'll be given some words in the array, and you have to find the shortest unique prefix that will help you to represent, or that will help you to decode or represent that particular word in the given array, right? Let's say if I give you zebra, so Z is the word here. Like, if I give you zebra, dog, duck and dove, so if I have Z, if I represent zebra with Z, so it can be represented, right? Because no other word will be having prefix Z. Like, if I have dog, so do, if I have do and dove, dove, so that is why I cannot represent dog with D, because duck is also there, dove is also there, right? I cannot represent dog with do, because do is also there in dove, right? So this is the way. So I'll be letting you know how we'll be doing it. So you can give me a +1 in the chat if everything is working fine, everything is clear, and then we'll be start. Okay, so let's discuss this problem, right? So this particular problem, as I said, this particular problem has been asked in Google and it has been asked in Microsoft, right? So it's a very good problem. So this problem is based on the concept of tries. So I'll be letting you know what is a try data structure, how you will be building it, and things like that. So you can be patient, a little bit patient, and what you have to do is you have to print shortest unique prefix for every word, right? So the question name is shortest unique prefix for every word. Shortest. Hi Shreya. Shortest unique prefix for every word, right? Shortest unique prefix for every word, right? Okay, so this is the problem that is there. Now in this problem, like, if I give you some words, like the words that have been there. So if I give you words like, let's say I give you dog, I give you zebra, I give you something like a dove, and I give you, let's say, what, duck, right? So if I give you duck, right, so all these are animals. Basically, I don't know, maybe the problem setters might be having some love with animals. Okay, so what you have to do in this problem is you have to represent each word. Like, you have to represent dog, you have to represent zebra, you have to represent dove, and you have to represent duck. You have to represent each word with a unique prefix, right? Like, if I have zebra, right? If I have zebra, can I represent this zebra with just Z? Can I represent this zebra with Z? Right? I can definitely represent this zebra with Z, because there is no other word which is having Z in the starting, right? So I can definitely represent it. Now let's say if I have this word dog, right? How can I represent this dog? Can I represent this dog with D? Can I represent this dog with D? Right? All of you can like the video and give me a +1 in the chat if my voice is clear and everything is working fine, right? And also the explanation is clear, right? So what you have to do is, if you have dog, so how will you represent this particular dog? So if I have to represent this dog, then can I represent it with D? No, I cannot represent it with D. Why? Because dove also has D and duck also has D, so it will create some confusion. So that's why I cannot uniquely represent it, right? Can I represent my dog with do? Can I represent it with do? Right? Can I represent my dog with do? Right? Can I represent it with do? If I represent it with do, so do is also there in dove, right? Do is also there at the starting as a prefix. Do is also there in dove, so that's why I cannot represent dog with do as well, right? So what I have to do is I should be representing this dog with dog only, right? Dog, right? I have to do this. I'm compiled. I have to do this simply because there is no other way, right? Now if I have this word that is dove, right, so can I represent this dove with D? Can I represent this dove with a D? Can I do this? No, I cannot. Why? Because if this dove is starting with D, so duck is also starting with D and dog is also starting with D, right? So that's why I cannot do it. Now, can I represent this dove with do? Can I represent it with do? Right? Can I represent this with do? No, I cannot. Why? Because this dove will have do and this dog will also have do. Right? So that's why I cannot. I cannot. Can I represent it like I'll be adding one word each time to my prefix so that I can see that whether I can represent it with this prefix, this prefix, this prefix. I'll be increasing the length of the prefix by one each time. So if I cannot represent it with do, so can I represent it with dov? Yes, I can represent it with dov. Why I can represent it with dov? The simple reason is because dov is here and here do only you have common, right? So dov is not there in any other string, right? So that's why I can represent it. In any other word there is not do, so that's why I can represent it. Now next up, if I have duck, right, can I represent this duck with d? Can I represent this duck with d? I cannot represent this duck with D because dog is also starting with D, dove is also starting with D, and duck is also starting with D. So this will create a confusion for me, right? Can I represent this duck with DU? Right, I'll take the next prefix. So I'll try to see whether I can do this with DU or not. Okay, so can I do this with DU? Yes, I can do this. Why? Because there is no other prefix which is having du, right? Is this part clear to everyone? Does this make sense? Please write yes in the chat if this much part is clear to everyone, right? And also like the video and please give me a +1 in the chat. A quick +1 in the chat so that I know that things are working up till here, right? You can write yes or a +1 in the chat to acknowledge that up till now things are very much clear to you, right? Okay, now the thing is that you will say perfect. Now how can we solve this question, right? How can we solve this question? So what I can do is I can say that for each word I might have to compare it with every other word, right? I can say that each word I have to compare it with every other word, like every like this substrate, like for this word dog, what I can do is like let me make it, like let's make it. So let me write it again. So if I have, let's say dog, if I have duck, if I have zebra, and if I have what, if I have dove, something like this, right? So if I have this, so if I have the particular word dog, if I have the current word is dog, right? So what I can do is, first of all, I want the shortest prefix that can represent it, right? So there could be three opportunities that I can represent it with, right? All the prefixes I'll see. So either I can represent it with du or dog, but I'll try to represent it with first of all d. If it's not possible, then I'll try to represent it with do. If that is also not possible, so I'll try to represent it with dog, right? So what I can do is I can compare this d, I can compare this particular string d with every other word of every other starting of every other word, right? So this matches, this also matches, right? So since there is a match, since d is happening again at the starting of some things, so that's why I cannot represent it, right? So I cannot use d, so d is being neglected, right? I cannot represent it using d. Now can I represent it using du? So that is something that I want to check. Can I represent it with du? No, this is also starting, this is also starting, right? So that's why I cannot. So what I'm doing is basically I'm comparing do with every other word, like this with this word I'm with this size, right? Do is of size 2, so I'm comparing it with these two words of this, these two words starting words of this, these two starting words of this, and the starting words of dov, right? So that's how I'm comparing. So can I say that whatever number of substrings that I'll be having, like whatever number of prefixes I'll be having, I have to compare all this with every other word in the worst case, right? Do you agree with me? Please write yes in the chat if you agree with me that I have to compare this d to check that whether this is not happening with anyone else. I have to compare this d with the starting of every other word, right? Every other word. Similarly, I have to compare do with every other word, right? Similarly, I have to compare do with every other word, with dove, with zebra, with duck, with dog, right? The first two words, right? What depends on the length. So that is what I have to do. If I do it this way, so this is a very brute force approach to do is this, right? And once I'll be at dog, so dog will not be matching with any other word except itself, so that's why it will be there, right? Anushka, it's clear to you, right? Anushka, is it perfectly clear to you? I hope that it is clear, right? So that is the thing that I try to check with every prefix of a particular word. I try to check and I keep on checking with every other word until I find a prefix which is not matching with the starting of every other word, with the starting prefix of that length with every other word, right? So this will take a brute force approach, right? This will take a hell lot of a time. This will take a lot of time. Please write agree in the chat if you agree with me, right? If you have D, OG dog. So first of all, you check that D is if the prefix size of this much size is having the same or not, right? Then you check with D, you duck, right? If you check with DO, then you check it with this and this, right? Like this. Then what you do is you check with DOG, then you will get, okay, no matching is there, right? Except itself, right? So that is what you'll see, right? Is this much part clear to you guys? I hope that it is clear, right? I hope that it is clear, right? Okay, so that would be a brute force approach to do it, right? Another optimal approach to do this could be using the advanced data structure that we have, that is trie data structure, right? Trie data structure. Does that make sense? Have you heard about the trie data structure? Let me know in the chat, right? And also like the video. If up till now things are clear to you, you can like the video and you can write a yes in the chat, okay? Right. So how can we do this? The thing is that, right? So what I can do is I can build a trie, right? What I can do is the trie helps me to insert a particular word into the trie. So I'll do that for you. I'll tell you like how does it get inserted in a trie, right? So if I have a root, the trie will always have a root, right? The trie data structure always has a root. Let me just move a little bit, make a little bit space for us to work. So if I have the word duck, if I have the word dog, if I have the word zebra, and I have the word as what, dove, right? These are the words that I'm having, right? Okay, even if you haven't heard, so there is no issue with that, right? So I'll explain it to very much. Like this is the root of the trie. This is the root, and from this is the root. Okay, this is the root of the trie. So forget about the root first of all. A trie is a data structure which behaves like an array tree. Okay, what does it mean? I'll explain you a little bit more. So a trie is nothing but it behaves. Think about it like a node. In a normal tree, a node has its left and right. I agree. You agree with me, right? You make a node that is left and right in a normal tree. You make it like that, right? This is what you do. But in a trie, you can customize it according to your choice, right? What you can do is you can have a node, and that particular node has 26 pointers, right? So it is used like this. It has 26 pointers, right? 26. This size is 26. 26 pointers, right? 26 pointers. This node, like earlier what happened? In a tree, a particular node has two pointers, a left pointer and a right pointer. But this trie node has a node in a trie has 26 pointers. If you are talking about the string, because there are 26 different lowercase alphabets, right? From A to Z, there are 26 different alphabets, right? From A to Z, right? So that's why. Please give me a +1 in the chat if up till now things are clear to you. I know a little bit of sound is there from behind, but just bear with it, right? Up till now everything is clear. Is everything clear up till now? Please write a yes in the chat, right? Okay. Now the thing is that if you have a tree, if you have a node of a tree, so it has a left, it has a right. Perfect. So like for a particular node, you have its left and right. But for a trie, right? But for a trie, you have 26 pointers, right? You have 26 pointers. What does it mean? So to represent the 26 alphabets, right? To represent the 26 alphabets. How do I do that? So I'll explain you a little bit more, but it has 26 pointers basically to represent all the 26 alphabets, right? Like the first would be representing A. If A is present, then you will mark A. Initially everyone will be null. Now if for this particular node, if A is present, then you will mark it as true, right? So you'll say that okay, A is present, then you'll add the next node, right? Something like this would happen. Another thing that a trie has, another thing that a trie can have here is frequency. Another thing that a trie can have is frequency. Like how many other words are there which are having this particular word included in it, right? This particular alphabet included in it, right? Suppose I make a node D and I have a node O. How many of them have, how many of the nodes have D? What is the frequency or what is the count of total number of words which are having the alphabet D in them? Anushka, am I clear that the count is nothing but 3? Because D is occurring here in the dog, in duck, in dog, and in dove. So can I say that the count of D is nothing but 3? Yes, like this, right? How many of the words are there that have count of O? Right? How many words are there that are having O? So can I say that the number of words that are having O is nothing but 2? This word and this word, right? Dog and dove. So the count will be 2 for O. Like if I make G here, from G, if I make G here, right? If I connect G here like this, right? How many? You can write yes in the chat. Shreya, Anushka, Mahesh, and others. Peaky Blinder. Everyone can write a yes in the chat if up till now things are clear, or a +1 in the chat, right? So now if you have a G, how many words have G in it? After D, after O, after G, right? As the prefix, how many words have G in it? So can I say that only this word is there G, right? Only this word is having as the third character, as the third character, as the third alphabet, only dog is having the word as G, right? So can I say that the count is 1? Does that make sense, right? That should make sense to everyone. So what I do in a particular, in this try node is, first of all, I'll check. Okay, so what I do is I insert all these words one by one, right? So this will be the root. So root will be having what? Root will be having frequency, as well as root will be having 26 pointers to the 26 alphabets. So if I zoom in, so it will have this thing, right? It will have the 26 pointers, 26 alphabets to pointing to the 26 alphabet. Since this A is having what? Since you have a, no, you have not, do not have I. So initially everyone will be initialized to null. A, B, C, D, everyone. But what will happen is, you will have a D. You will have a D. Right? You will have a D. If you have a D, so you will say that you have a D, right? So you'll generate a node of D, right? Like in a tree, if you have a left, so you build a new node of left, right? If you have a left, if you have its left child existing, then you make a left, right? So that is what you will be doing here as well, right? So if you have a D, so you'll be adding it here, right? You'll be adding it here, right? So what will happen? What will happen? I'll add a D for this particular node. So for this node, I'll add D, right? So this will have a D. This was the root. It will have a D. Now, if like I'm building duck, okay, first of all, I'm trying to insert duck. So let's bring duck here, right? Let's bring duck here. So we have duck. So I'm inserting duck. Okay. Now for this, now my current is standing here. Okay. Every time I'll start my current from the root. For inserting the word, I'll start my current from the root. I'll check. Like D was not existing, so okay, that's perfect. Now my current is at D. Now for this D, which is the next one that is there, U. So I'll say okay. In the particular array that I have, I'll mark U position as a new node. I'll make a new node U. So I'll make it. I'll say okay, I'll make it. So I'll make it, and it would look something like this. This U would be inserted like this, right? Something like this, right? Okay. After this, I'll move to the next pointer. So I'll move to the next alphabet, that is C. For this U, it is behaving like a node. So it is having also 26 alphabets, right? Like this. So it will also have a U, like this U, this will be my current, right? This would be my current, because this is the current pointer. Up till now, are things clear to you, Anushka, Shreya, and others? I hope that things are clear to you. I'm trying to explain in the simplest way possible. You can write a yes or a +1 in the chat, so that I am acknowledged that things are working fine for you guys, right? Okay. Now the next thing is that for this particular U, I need to have a C. So I'll mark a C here, right? I'll make a node of C here, right? So I'll make it. I'll say okay, let's make it, right? So I'll make it. So I'll say okay, let's make it. So I'll make it, right? So I'll make a C here. Once I've made a C, so what will I do further? If I made a C as well, so now my current would be standing here, right? I'm inserting this particular word into the try data structure, right? I'm at this point, I've inserted C. Now now my current is standing at C. Now for this node C, I'll have a 26 array, right? So for this, I want a K. right? For after C I want a K, right? So I want a K. Is K already, for this C, for this particular C, is K already existing? No, it's not. So that's why I'll insert a C, right? So I'll insert a node. So this is what would happen. Like I'll be telling you the code, so you don't need to worry about that as well, right? So I have duck, right? So I'll insert K. So I'll say, okay, let's insert K. I'll insert K. I've inserted K. Just give me a second. Right. I'll insert K. Something like this, right? I'll say okay. I'll say okay, this word is done. Now what I'll do is I'll say what was the count of, like in the word duck, right? In the word duck, what was the count? Can I say that the count here was 1? D is occurring. This is the first word. Up till now, I've inserted only D into my try, only duck into my try, and duck D is occurring one time. Like only this word is there, which is having D as the starting prefix. Then here also the count is 1. Like for you the count is 1. Then for C also the count is 1, right? So every time I'm inserting a new word, like I'm moving to a new word, I'm updating my frequency, right? So I'll say that the count is 1. Update up till now everyone's count is 1. So to just minimize things, I'll just write C is equal to 1 here for indicating that the count of the frequency is 1. Okay, so I'll say okay that maybe C is equal to 1. C is equal to 1 here. C is equal to 1 here. C is equal to 1 here. Right. Perfect. Now what will happen? I have this dog. I have this word dog. What I will do with this is I'll start from the root. So what will I do? I'll update my current to root again. Okay. I'll say current is equal to root. Okay. I'll say current is equal to root. Once I have my current is equal to root, so from the root, I have this 26, right? I have this 26 alphabet, and D would be somewhere here, right? A, B, C, and D, right? So do I have a D node already existing for the root? For my current, that is root. For my current is standing here only currently. So for my current, do I have a D? Do I have a D already existing? Yes. Yes, I have. Yes, I have. So I'm at this particular word. I'll update my count to 1. I'll update my count to 2 because this is the second word which is having D as the starting. This is the second word. So I'll update my count to 2. And now my current is standing here. Now my current is standing here. Now what I'll do is I'll move to the next word. I'll move to the next alphabet. So the next alphabet is O. For this particular D, it also has a 26 representation, right? So does it have a O? No, it has a U, but it does not have a O. So that's why I'll be inserting it for the first time. So I'll say that okay, I'll mark its frequency as 1 and I'll insert it. So this is something that I will do. O. And my current would be marked here as 1. Count would be marked as 1. Current would move here and the count would be marked as 1. Now this is my current node. Now I'll be at G. Now for this particular O, does a G exist? No. So I'll say okay, I'll add a G as well. So I'll add a G as well. Right. So let me change the color and I'll add a G. I'll say okay, I'll add a G. Now for G also the count would be 1. Right. For G also the count would be 1. And now I've inserted this particular word as well. Notice that I have inserted this particular word as well. Right. So for this also the count is equal to 1. Here also the count is equal to 1. Right. Now what will happen? Up till now things are clear to you, everyone, right? Now I'll have zebra. So if I have zebra, so do I have a Z? No, I don't have a Z. Right, currently I do not have a Z. So for the current, like I'll update my current to root, and for this particular root, it's 26 array. It's 26 size array. Do I have a Z? No, its last pointer is not pointing to any node, right? So it does not already have a Z. So that is why I'll make it from null. I'll change it and I'll insert a new node Z. Right, I'll insert a new node Z. Now for this Z also I do not have any E, so I'll insert an E. I'm not explaining this because I've explained for the previous things. Right, I'll have a E. I'll have a B, I'll have a R, and I'll have a A. This is what I'll have. Now the next word that I have. What's the next word that I have? The last word that I have is dove. I'll say okay, I have a dove now. What do I need to do now? Okay, what do I need to do now? So what I'll see is this is the situation up till now. Now what I need to do is I have to insert dove as well. So counter is here too, right? Because D has occurred 2 times in the starting, right? For duck and dog. Now I have a D. So current is pointing to root. This is the root. So for this root, it's 26 representation. Does it have a D already? Does it have a D? Yes, it has already a D. It has got a D. So that's why I'll not insert a new node D, but rather I'll move. So I'll say current is equal to, like you do the current, if left is existing, if left is not existing, then if you want to add it, if you want to add a new node, so you'll add it. Otherwise you will say current is equal to current left, right? So that is what you'll do. Current is equal to current D. So you'll be moving to the D node, right? You'll be moving to the D node basically. Now once you move to the node D, so you'll increase its count by 1. You'll increase every time you are moving to a node, so you're increasing its count by 1 if it is already existing, right? If it's not existing, so you're making it as 1, right? So the count becomes 3 here. The count becomes 3 here. Now from this D, do I have a O? So for this particular D, it's 26. In the 26 representation, I can see that this particular D, this particular current, this particular D, this particular current already has an O. This particular D, please like the video if up till now things are clear to you, right? I've tried to explain it in the simplest way possible up till now. So this is the current, right? This is the current that I'm having. So for this particular current, for this particular D, do I have a O already existing? Yes, I have, right? So this O is already existing. So that means I can move to this O and I can update its frequency by 1. I can move to this O and I can update its frequency by 1. So earlier the count was 2. Now the count would become, earlier the count was 1. Now the count of O would become 2. Okay, I'll say perfect. Now I do, from this O, do I have a V? From this O, I have a path going to G, but I do not have a path going to O. From this O, I have a path to G, but I do not have a path to V, right? And I want to insert V. So I'll say, okay, let's insert V. I'll insert V and I'll mark my counter as 1. I'll say, okay, that's good, right? Now, next thing, what I'll do is, I'll say, I need to insert E. From this V, do I have a node E? No, I don't have up till now. So that's why I'll insert E and I'll say counter is equal to 1 for it as well, right? This is what will happen. This is how I have constructed a trie data structure. Please write yes in the chat if up till now things are clear to you guys, right? Perfect. Now all the words are inserted. So what I'll do is I'll iterate through each position and now I'll generate the prefixes, right? So like for let's say for duck, right? Let's say if you have duck, D-U-C-K, duck. So I'll see from the root I move to D, I move to this particular node D. Now is this D having a count 1? Does this D have a count 1? No, it does not have. So that means just using D to represent duck will not help me. So now I'll move to U. So I'll move to U like down here. So does this U have a count as 1? This U has a count of 1, right? This U has a count of 1. And since it is having a count of 1, so that means that this particular prefix DU is unique and it is not used by anyone. This D was used by 3 people. But this U is unique to this. So I can represent duck as the shortest prefix. The shortest prefix with which I can represent duck is DU. Because the count for U is 1. Because it is not occurring in any other string for the second alphabet. As the second alphabet. Right. I'll say okay. I can represent duck as DU. Right. So I'll say that okay, I can represent duck as DU. Like let me write it here. So I can say that okay, I'll represent duck as DU. Now I'll come to dog. Now for dog, what I'll do is I have this particular thing, right? Now for dog, if I move to this D, can I represent this dog with D? No, I cannot, because it is, please write clear in the chat up till now if things are clear, right? So I'll say, can I represent this dog with D? No, I cannot. Why? Because it counter is 3, so I cannot represent it. Can I represent it with DO? If I move down to this O, can I represent this dog with DO? Can I represent this dog from this D? I move to this O. If I move to this O, so the count of O is 2. Count of O for as the second alphabet, there are two words which are having O as the second alphabet. There is dog and there is dove. So that's why the counter was 2. Since the counter is 2, so that's why I cannot represent it as DO, right? Because its counter should be 1. Now I move down, so I move to G. The counter for this node G is 1, so I can say that I can represent it as GOG. So as I told you, as we already saw that we have to represent dog as DOG, right? So I'll represent it. I'll say okay. I'll say perfect. Let's represent DOG. Now I have zebra, right? So if I have zebra, so I can definitely say that counter is 1 here, counter is 1 here, counter is 1 here, counter is 1 here, right? So since the counter for Z is 1, so I can represent zebra with Z only, right? That's perfect, right? I can represent zebra with Z only. I'll say that okay, I can represent zebra with Z only. So I'll say okay, I can represent it with Z only because like the count of Z is 1. Now what I'll do is I'll move to dove. If I talk about this particular word dove, so what I do is I move down to D. D is having C is equal to 3. D is having a count of 3. So that means the number of words which are having the first alphabet as D are 3. So I cannot represent it with D. So I cannot represent it dove with D. Now I move to O. Now O count is also 2. The count of O is also 2. So I cannot represent it with O as well. Right. So DO cannot represent dove because it will match with dog as well, right? So that will create a confusion. Now can I represent it with, now I move from O to V, so I move to V. Can I represent it with a V? Can I represent it with a V? Yes, I can represent it with a V because the count of V is 1. So that means that I can represent it with DOV, right? I can represent it with DOV because that's unique to dove only, right? Because this particular prefix is not occurring anywhere else. So I can represent it with DOV. So this is how I would do the question, right? Is up till now, is everything clear to you guys? Just let me know in the chat. Just let me know in the chat, is everything clear to you guys? Is the try data structure concept and everything clear? Like you can observe that this question was asked in companies like Google and Microsoft, and these are the companies that we aspire to work for. So they have asked this particular question. So definitely you should check out this question. That's why I'll always emphasize that you should be solving the problem of the day on Geeks for Geeks regularly, right? Does this make sense to everyone? Okay, right. So this is what you have to do. Let me show you the code part. What you will be doing in the code part. I declare a try. I declare a class of try, right? Let me be specific. So you can also declare a struct of try, but class of try is also perfect. So I declare a try with 26 alphabets, right? 26 alphabets. So if I have A, if I subtract A minus A, so it will give me what? 0. A minus A is 0. Then B minus A is what? B minus A is also 1. So this is how I'll be representing it, right? I have not made a character array because the indexes are 0 to 25, right? Indexes are 0 to 25. So if I do A minus A, it would give me 0. If I do character B minus A, it would give me 1. So this is how am I representing it. So if I do Z minus A, so it would give me nothing but 25, right? This is what would happen. So I'll say okay, I'll say perfect. This is how I'm representing it, and I'll have the count as well. Now I've declared a constructor for this try in this class. So what I've done is I've for all the 25 all the 26 alphabets, I've initialized them to null, the pointer to null, and I've marked my counter as 0, right? Then what I've done is I'll be given this particular function, right? I'll be given this particular function, that is this function, right? Where I have to find the prefixes, right? I have to find the prefixes. I'll be given the array of the strings, and I'll be given n, that is all the strings, right? So what I'll be doing is I'll declare a new try. I'll declare a root. Once I have the root, so what I'll do is I'll insert all the n words into the try. This function will do what? This function will insert ith word, insert the ith word into the try, right? What does it mean? It means that first of all maybe I'll insert dog, then I'll insert duck, like this, one word by word I'll be inserting it into the try. So like this is the insert function that I've made, in which first of all I'll be passing the root as the current root, right? And I'll be passing the word. What I'll be doing here, let's check out. As I told you, right? As I told you, it's as simple as that. So what I'll be doing is I'll be iterating through the length of the word, each character of the word. If that particular character, if from the root, if the root is nothing but indicating the current node that I am at, if from the current node, if the character that I want to go, if it is equal to null, then in that case I'll make a character, right? I'll make a character, right? That's perfect. I'll make that particular node, I'll generate that particular node. Otherwise, if it is already existing, then I'll simply move to it and increase its counter, right? This is what I will do. You can write this part in else also, but that doesn't matter. So like you can do this way also. So if a node was not existing, so you'll add it, and then you'll increase its count and you'll move your root to that node, right? That is what you will do. Now this way your trie would get constructed one by one, as I told you in very much detail. Now what will happen is you will iterate through all the words. You will have a string answer that for which will be having the shortest prefix, which you can represent each word, right? So first of all, s will be array of I, right? So current element, so you'll again mark your current and you'll be iterating through that particular word. And if for any particular node, of that particular word, for any particular node, if the count is 1, then you will say that you can represent it, right? So you can either say that answer plus is equal to something like you can either say that temporary plus is equal to s of j. You can either add it like this, or you can also say that from this, starting from 0 up till the jth index, that your string is existing, right? Up till the jth index, so you will add this particular substring 0 to j plus 1, as I told you, right? If suppose dov, v is having the frequency 1, so you'll store what? You'll store the substring dov, right, in your answer, and you'll break for this particular word, because for this particular word you would have stored the string. So you'll then move to the next word and store it, and in the end you just simply return the answer that will be storing all the smallest prefix representation of all the words, right? This is what it will be doing. So for doing this much, the time complexity of the code would be nothing but n into length of each word, right? The time complexity would be nothing but n into length of each word, right? The time complexity would be n into length of each word, right? Like for one word it would be its length for making the trie, then for each word if you are doing this, so it would be n into length of each word, right? And similarly the space complexity will also be the same, that is n into length of each word, because you are generating for all the words. Suppose all the words are unique, so that means n unique paths would be there from root to node, from root to leaf, right? So that's how it will be done. This question was asked in Google and it was also asked in Microsoft. So thanks a lot for watching this video. We also have a channel, that is Code Era, so you can consider, if you like my explanation, if you like the things that we are doing, so you can consider to subscribe our channel, that is Code Era. On this channel we are doing lead code daily challenges, live streams, lead code weekly challenges, we code bi-weekly challenges, code forces editorials, ad code editorials. So thanks a lot for watching this video. If you have any feedback, so if you like this video or anything, you can let me know in the comments after this video is over. You can write in the comments and I'll be more than happy to reply to your doubts or listen to your feedbacks, whether they are constructive or they are positive. So thanks a lot for watching. I'll see you soon in the next video. Till